Okay, next let's say here we have value, say 42, and then we would like to print that out in binary. All right, look at the ones and zeros of it. Okay, so that should be simple enough. We have some processor command we can call and we'll just print it out in binary, right? If only life were so simple. No, I'm afraid we're gonna have to write that ourselves. Okay, so I'm gonna make a little subroutine, I guess, to print in binary. We've already figured out how to check for ones and zeros, right? So what we need to do next basically is just check one slot in the binary spectrum, and the way we do that is using test. Let's see, but hang on. First, I'm going to be using A down here for some other things, and an A here. There'll be a little confusion, so I think right away in print binary I want to move A into B. I'm just going to go move instead of using push and pop. I have B free. Just quick and down and dirty there. Great, and so now I can test BX. Great, and I want to test a specific location in BX there. Okay, so no, I could like if I tested location 0. Yeah, let me bring up oh gosh. Okay, I made see if this works. I made a nice chart, but I didn't load it into my there. I'll just go full screen. There, it's as full screen as this version gets. Okay, there you go. There's the values there. So if I wanted to check value 1, I could using test. Mean that would be the least significant bit, right? So if I want to check the most significant bit, the highest number, that would be 1 0 0 0 0 0 0 0 0 0. If I want to check that first bit, that is 8, which 8 in hex, OX 8000, which is the actual numerical value, 32768. I remember in the stacks tutorial, I said I estimated that there was about 35,000 in the stack. There's exactly 32,768 places in the stack there, because it's all like binary. That's your max number, right? Okay, let's get out of there. I hope that was explanatory enough. So if I wanted to test the ones place, I could do that, right? But I want to test the top of the list, basically, right? So let's see where we are. Jumping out 0, load to 1. Print it, move out. Oh, and one down here in the one more thing. I'm printing 16 characters, right? Where is that? Move BXAX here in the print binary. I'm also I'm gonna set my counter to 16. Now I want to print out all 16 bits. And here I'm going to create a loop. Print loop like that, and then just copy that. I'm going to go down here into my print command, and right after I call the interrupt, we will loop, print loop. Okay, so if all went right, this should loop 16 times. Okay, let's have a look. I'm going to save this, see how many errors we get. Oh, look at that, looped 16 times, didn't print out any values. Why is that? If, what am I, one more thing, I'm not, oh, okay, one more thing to cover here. Let's say, I got a binary value, right? Okay, and then so we're looking here in the first most significant bit. It's actually more like that, you know, whatever. Most significant bit, right? There, right? If it was least significant bit, that would be beginning at 0. Okay. Now we're checking this one first, right? Then we want to check the next one and the next one and the next one. Well, how do we do that? Well, you recall our list. Don't launch Photoshop all over again. Sorry. You recall our list where, let's see, this was the 8,000. This would be 4,000, 2,000, 1,000 in hex. Right, so I need to go down that list, right? So that means I need this value, and then half that value and half that value. See, interesting thing about binary. Here is a value of, let's see, if this was, here, let's do it this way. There's a binary value of 1, right? If I move this to the left, like this, 1, 0, it is a value of 2, right? I've doubled it. It's twice as much. If I move this there, I've doubled it again, you see. So each time you go 1 to the left, you effectively multiply by 2, you know, just like in decimal, you know, every time you add a 0 at the end, you multiply by 10. You know, if you got 10, you put another 0, you got 100, right? Times 10. Well, here it's binary, power of 2, so, you know, every time you add a 0 at the end, yeah, it moves 1 to the left. Okay, so I hope I haven't said that too many times over and over. But what's missing here is the part where I move everything to the left. Shift left, BX 1. There, we're going to move 1 to the left. The binary value, and hopefully that will iterate through the list. Let's see what happens here. There we go. There is 42 expressed in binary. It is 0, 1, 0, 1, 0, 1, 0. You see. There we go. So this is a subroutine we have created to interpret a value and convert it into a readable binary.